Hello everyone, thank you for joining me today as we talk about complex systems. To begin, let's talk about what they are. System is defined as a set of things working together as parts of a mechanism, and complex is defined as composed of many interconnected parts. And so the way that we describe or define a complex system is one whose overall behavior is difficult to understand based simply on knowledge of the components of the system. We also need to understand the interaction between those components. The way we depict complex systems is using networks, or the study of network science. Many people ask me, what are networks? And what I always like to answer is, networks are simply connect the dots, where you have different components in your network. Those components can represent, let's say if this was a neural network, those components would represent neurons, and the connections between them would be the synapses between those neurons. Or if this was a social network, the components would represent people, and the connections or the interactions would be a friendship relationship. Now, networks are described by graph theory, which is simply the mathematical formulation of networks. So let's talk about some basic graph theory concepts. To begin, let's talk about a friendship network. Each of our components are represented here by people, and those are called nodes. Now, there can be connections between these people. For example, a friendship between this person and this person, or this person and this person, and so on and so forth. These are called links. Now, you might notice that these connections are simply lines between the two. There's no direction. There's no arrow pointing one way or the other. The reason for this is because for this specific network, this friendship network, one person is friends with another person, and vice versa. It is a mutual interaction or a mutual relationship. So this is called an undirected network. And as you might have guessed, there's also such thing as a directed network. Let's talk about one. A communication network. Again, here, our nodes are represented by people, and links between them are when one person calls another person. So let's say this person calls this person, or this person calls this person, or that person were to call this person. Now, again, there's a direction here because one person is calling the other. This is not a mutual interaction, and so this is called a directed network. Let's talk about another characteristic of graphs or networks, which is degree. Here we have a power grid network where the nodes are electrical towers and the links are undirected because with the power lines, electricity can run from one electrical tower to the other and also in the opposite direction. Now, the degree is a characteristic that belongs to an individual node. The degree is defined as the number of links to other nodes. So this node has degree 1, 2, because it has 2 links to other nodes. But let's map this out. Let's plot the degree versus the probability of having that specific degree. Now there are 4 nodes, so our probability is broken up into 4 parts of 0.25, 0.5, 0.75, and 1. So this first node here has degree 2. The second node has degree 1, 2. This third node has degree 1, 2, 3. And this fourth and final node only has one link to another node, and so its degree is 1. Now adding these probabilities up, we have 0.25 plus 0.5 plus 0.25, which is equal to 1, which is great because probability always needs to be normalized. Now one more thing about degree that we often calculate is the average degree of a network. That is simply the sum of the degree of each of the nodes divided by the total number of nodes. So that would be 1 plus 2 plus 2 plus 3 divided by 4, because there are 4 total nodes, and that is equal to 2. So the average degree of this network is 2. Another concept is paths and distances. A path is simply the route along the links that connects two nodes. And so if we want to find the path from 4 to 7, we could start at 4, go to 3, 3 to 2, and now we have an option between these 3 links. Let's choose this path: 2 to 1, 1 to 5, 5 to 6, and 6 to 7. Now, as you might have noticed, there are multiple paths in which we can take to get from the same node 4 to 7. But what we often care about in network science is the shortest path, which would be this blue path. Because for this path, the distance is shorter than any other in this network. Its distance is 1, 2, 3, 4. The next concept we're going to talk about is connectedness. Here we have 2 components or 2 clusters. The definition of a component or cluster is that any node within it can be reached by any other node, can have a path to any other node in that cluster. For example, if I want to get from 1 to 3, I simply travel along this link. Or for this cluster over here, if I want to get from 5 to 6, I travel from 5 to 7 to 6. Thus, I can get from any node in this cluster to another node. This is called an unconnected network. Now, if I were to form a connection here, this is called a bridge, which is a connection between 2 clusters. This is still not called a connected network, because the definition of a connected network is when every single node in the network is connected to every other node. For example, 1 is connected to 2, 3, 4, and 5. 2 is connected to 1, 5, 4, and 3, and so on and so forth. Using these concepts, we can apply them to larger scale networks, so we can understand their structure, and thus better understand real-life complex systems. An example of a real-life complex system is the Human Disease Network, which was published in PNAS in 2007. Each node corresponds to a distinct disorder, colored based on the disorder class to which it belongs. A link between disorders in the same disorder class is colored with the corresponding dimmer color, and links connecting different disorder classes are gray. The size of each node is proportional to the number of genes participating in the corresponding disorder, and the link thickness is proportional to the number of genes shared by the disorder it connects. This network, along with social, power grid, neural, metabolic, and epidemiological networks, are all important to understand the complex systems that they attempt to depict. Thus, studying the basics of graph theory is important to be able to study networks, which in turn help us to understand the physical universe that we live in that is made up of complex systems.